Hello, everybody. Welcome to our meetup today. It's all about MicroStream version 7, MicroStream version 7 overview. And so we have worked on great new features. And so we want to share this latest news with you today. Today we have a special guest, Ottavio Santana, from our great developer community. And let's have a look on our agenda first. So we will start with an overview about the new features in upcoming version 7, what we have done the last 6 months. Then we will talk about our new CDI extension written by Ottavio. He will introduce the CDI extension for MicroProfile runtimes. Then we will talk a little bit about the upcoming MicroStream Cluster for distributed object graphs. Then we will talk a little bit about the new release cycle. So we have changed some we have changed the release cycle, and so this is will be very good for you guys, because we have increased the free support, the free update support for another 6 months. And then we have time for Q&A. So this session will be recorded, by the way. So if you have questions, take the chance. Florian is also on the call. He's our CTO. And also Christian is in the meetup today. He's our developer advocate and project manager for several customer projects. So let's keep it interactive. So if you have any questions, take the chance and ask some questions. Okay, let's get started. What's new in the version 7? So we have worked on really great new features, but what's in the core framework? Are there really great changes also in the core framework, or is it more like bug fixing and keep the version stable? Florian, what would you say? What's new in the version 7 in the upcoming new version?
Yeah, we did a lot of bug fixes regarding memory consumption was the main concern, but we have great new features, the CDI extension from Ottavio, the serializer API, and parts of the upcoming replication and cluster features. And these are the core elements of the new version 7, which will be released in April, so about in about 3 or 4 weeks. We have 2 betas out already, and I show you later how to get the beta releases to check it out.
Okay. Then let's jump right into the CDI extension. Ottavio, hi. Great to have you on the call today.
Hello, everybody.
Hi.
I'm glad to be here as well. So, hello, Marcus, Florian, Christian, Harold, Marcel, Rudy. How are you? So, let's talk about the newest thing with CDI. May I show my screen? I love to do code just a little bit. Okay, let me share right now. So hopefully you're able to see my screen,
yes.
Right?
Perfect.
So basically what the main goal of the CDI extension, to make that easier to work with Java or any kind of Java specification. Right now here, I will show only Java with CDI 2.0 that has support to Java SE. But when you think about specification, think about, okay, based on that, I will be able to work with MicroProfile and Jakarta implementation. So we will have support to Payara, to Eledon, to OpenLiberty, and so on. The sample that I have here is really simple one. Simple. It's a Maven product with Java SE. It is the library. So basically the CDI integration and our dependencies. Right now we need both. We need to run with Java CDI version 2.0 or higher, or um, Eclipse microprofile configuration, sorry, and Eclipse microprofile configuration implementation. So with those, basically what I need to do is to create a name service. This is a small sample here where I have my class with names, and I have this element with immutable entity fields. So right now I'm using a string because string is immutable. However, if you want to, we are able to create your own entity as well. So basically I will run this sample here, and then I will increase with a more complex one. So I have my name here, that's my storage. I have my service. As you can see, I'm just inject this sentence here, and then I will include the fields. Based on that, it will inject and then run the whole information. So I run first, just use cd log. And the second time, as you can see here, I will have some information. So let's run here because the information is there. So let me try to mvn clean. Okay, Otav, why do you need the properties from Spring configuration? Basically, I have the tight integration between a MicroStream where I'm able to define several ways to pull this kind of properties. So for example, here, I defined the start directory where I put in target data, the count, and to start the information as true. So with that, I can, let's close the tabs here. I can inject the manage root and then do this kind of operation. Okay, as I said to you before, yes, if you want to, we can create a simple sample, for example, product, where I do have a private final string with the name and 18. Remember, the elements as recommendations should be immutable. So what I'm doing here is basically creating a immutable entities. So right now I will do a choose string here. And based on that, what I'm gonna do, I will update the names to use product. I will rename 1 second to product as well. And yes, I will update everything here to product, product, product is required. And here you go. And then when I come here, my entity is updated to this little product here. So product, and here you go. I have everything updated to use product instead of a single name. And also said that the next step is basically create these products. So I can do a product, a new product. So a new product where I have 2 fields. One is the name, another one is the rating. So I can do this kind of thing here. just to save us a little bit of time. Just put random numbers, just to save us a little bit of time. Okay, basically what I did here was to update the sentence. Right now, it doesn't make sense to call names, so can rename this to inventory. So select everything, products, and yes, I need to override the equal to hash code here, right? So I need to come here, equals hash code. I will use the same. So right now I have this guy here, and here you go. I updated the sentence to use the product, and let's see what's going on. So it will run. Sometimes there's nothing here. And then the second time, as you can see, the root value is new. Because remember, it's in the target, and then I did Maven clean. And here you go. As you can see, I updated the root value with names, where, as you can see here, is my product. So basically what I did here, I have my inventory that represents my storage information, and I put the storage annotation that is extension belongs to CDI. Inside my service, I inject the inventory, and then I did a kind of transaction operation where I put the store annotation. Basically, it's a CDI interceptor to make my life easier to define. Okay, it is time to store that information to me. Do it for me. And that is it. So is there any question? And just to highlight, it's a CDI. So as you can see, JavaX inject, it belongs to CDI. And because of that, we are able to implement you are able to use as much you want. So any kind of CDI implementation. If there's no questions, thank you.
Thank you, Ottavio. Fantastic, great job, and this will help us will help the developers to get started with the MicroProfile-compatible runtimes.
Yes, it will.
Okay, great. What's next? Let me share a screen, please. One of the most asked questions in the last years was, can I build distributed applications with MicroStream, and how can I run multiple instances, MicroStream instances, using one and the same storage? And until today, MicroStream is a single instance storage, which means you can use MicroStream for running one MicroStream instance that stores data in a storage. One MicroStream instance can also store data in multiple storage. So this is also possible. This is no problem. Running multiple MicroStream instances that store data in one and the same storage was not possible so far. So this is the reason why we worked very hard on a cluster solution that enables you to distribute your object graph through multiple instances. And so we have introduced this very first prototype at the MicroStream Summit last year in November. And so now we had some more months to work on the MicroStream cluster, and let's see what we have done the last weeks and months. Christian, do you want to get started, or Florian?
Yeah, I will start. So let's give me the chance to share my screen. Should be great. This one. Now you will be able to see the first slide. So thank you, Marcus. It's a great pleasure for me to provide those informations, and I have to say it beyond version 7 because beyond version 7. I love this word beyond. It sounds like, yeah, in a way it sounds for me like really future stuff, and that's great. So let's talk a little bit about all about that cloud storage stuff, or the cloud storage solutions. These are three, I would say these are three products or three services that we provide in the future. And I also have to say, this is everything what you see here is still work in progress, but especially the first service and the second one are really close to final. Some tests are, of course, are necessary, but yeah, we are really close to finish this. So let's get into it. The first thing I want to talk is the MicroStream remote storage service. So what does that mean? Or what is the idea? The idea is to have the possibility to just book managed MicroStream storage within the cloud. This is at the moment we are only, I would say, a framework in a way. So, but in the future it will be possible to book this within a cloud, and you no need any thoughts about architecture or infrastructure. That's important, and everything is fully managed. So of course you have to do some configuration stuff, especially for the backups or especially for vertical scaling and so on, but in the end it's full managed, and you don't have to care about that architecture infrastructure stuff. So that's really great. And another special thing is, as I said, it's the first time we are able to provide MicroStream as a service in the cloud, and that's also really great. Also on the AWS cloud, and this is also for everyone who asks, okay, AWS, I know this, but most of the time I use the Azure cloud. We focused at the moment to the AWS cloud at the beginning, but in the end we will add these services also to different cloud providers and also to our own MicroStream cloud portal. But yeah, we start with AWS, and in the end I think it's easy to move the technologies to different cloud providers, so that will be great. Another a great opportunity is to get MicroStream also running on AWS hybrid cloud solutions, especially for on-premise. So that means when you use an Azure cloud, for example, on-prem, or an AWS hybrid cloud on-prem, you will get the MicroStream technology, yeah, let's say out of the box. So that's really great. So, and also so for some technology stuff like AWS Private Link and so on, this is really great to provide MicroStream as a service. And that's the basic idea of all the products I share with you now. So let's get into it. What is the remote storage? And just a short explanation. You can see here the MicroStream basic approach. So we have a normal application, a normal server application. And as you know, so far, we have MicroStream in it. It's a normal embedded storage. And we are able to store the data to plain file, to relational databases, or to blob storages, and so on. That's basic approach. Then there is another approach we use most in the past. It's a REST approach, I would say. So on the right side, we have a storage server based on MicroStream. And we store, in this case, we store the data to a plain file storage. And on the left side, we have a lot of different applications. It doesn't matter what kind of application there are. It could be an Android application, web application, or any application like SAP and so on. And all these applications are able to get the data via REST from the storage service. And the biggest advantage, I would say, is that we have on the left side the possibility to horizontally scale these applications, because in this case they are stateless. So that's really great. But this is the second approach. And now when we mix up these two approaches, the basic approach and the REST approach, so we will get our remote storage. And let's imagine we have a client or customer app here on the left side, and we only need a small layer of MicroStream in it. It's called normally it's called embedded storage, but in this case we call it a remote storage provider. And after that, in the middle here, you have to book, or you have to order a MicroStream remote storage gateway. We call it like this. And this is the way the data is provided. And then you have to decide which kind of storage you want to use. For example, you are able to use AWS S3, for example. You can also use S3 as mounted within EBS, for example. And of course, you also can use a normal, straightforward Docker volume to store the data. And in the end, it works like, it simply works. You order it, you use some small lines of code within your application here on the left side, especially the IP address to access to the service. And this is the way we provide the MicroStream cloud solution in the future. And as I said, this is, I would say it's finished at the moment. We have to do some testing on it. And after that, we bring these to the AWS cloud, and you will be able to order this. The first one is the remote storage. A second project, or a service, or more, I would say a feature, is the object graph replication. So what does that mean? The idea is if we have multiple storages and we want to do some synchronizing stuff between them, so we need to have the possibility to send changes of the graph, and also, I would say, changes in a subgraph to different storages, and they merge those changes in it. So it's a synchronization, I would say. We can do this with a Kafka cluster, for example, as a cache layer. So first the informations will go to Kafka, and you will have kind of like a history in that Kafka cluster, and all the other storages will get the information out of the cluster. Or the second one, at the moment, as I said, it's still work in progress, but this is also possible to do a direct socket connection to a different MicroStream application, or to a second storage, and then you will have those synchronized mechanism in place. And now imagine a second advantage is, based on that Kafka cluster, we have a history of all changes, of all adds and all deletes, and we can build a new storage from scratch out of that Kafka. This is also a great solution. So I'm pretty sure some of you would say, okay, sounds great in a way, but I don't have any use cases at the moment. So I will provide you two use cases. A very small one, for example, is like this. Let's imagine we have two servers, one European server and one North American server. Both are the same application, but let's say different server clients, or like this. The special thing here is we have, instead of one storage, we have two storages here on the bottom, and the left side one is the storage with all that base data stuff. For example, products or users, for example. These are data which changes not that much. So I would call it base data. And we have a second one. This is the transactional data. This is data which moves all the time and changes all the time, like, yeah, for example, orders and so on. And the great thing is we will be able with that merge to send changes on the base data, for example, from the European server to the North American server, that they can use also that base data. So this is the synchronization. And this is, yeah, as you can see here, this is one way. So it goes only from this side to North America in this way, but there will be, we will be able in the future to update or send update requests by REST, for example, to the European part and so on. So it's totally up to you to create this. The reason why we have two different storages in this case is at the moment, the graph replication is a read-only thing. So when the data is replicated on this side, this is, or this should be, I would say, read-only. From the technical side, you will be able to do also changes, but you have to take care about data consistency by yourself. That's important. Technically, I would say it works, but it's up to you to be careful when you also update the data here. I would say in some cases it might be more easy or much more secure to create a second way, maybe the REST approach to send data back to the European server and then store it to base data. So this is only a small use case. I'm pretty sure there are thousands more, but in the next part, I will hand over to Florian, and he will do a really small demo of the replication itself. And then I came to my second use case, and I'm pretty sure this will be more important. Florian, it's your turn.
Yeah, thanks, Christian. So just let me share my screen. And yeah, first of all, like I said in the beginning, on our GitHub page, you can see the release info for our beta releases. Here's the beta 2, which contains special type handlers for Android. We had to implement because of ongoing security restrictions regarding reflection under Android, so we have to keep up. But now we are able to use all the date types again, and in the beta 1, we had the CDI extension, the logging, and the serializer API, and a few bug fixes. Of course, it's available in Maven Central. Just add it to your project as usual. All right, so now we're coming to the replication part. With the small application, we have our data root, which contains a list of entries. This entry is just a consecutive number and the timestamp of creation for displaying purposes. So we have a master or write application. It's one JVM running somewhere on a node, in the cloud, wherever. And as you can see, we have a default storage manager, which has one extension to it, is a data distributor, which uses Kafka in that case. Will provide different transport layer adapters in the future. For now, we have Kafka and socket layers, and that's pretty much about it. You only have to define a distributor, and it keeps track of all changes made to the storage and sends it out to all interested other nodes. So for demonstration here, we have a small web server to show something in a browser, and the test reader, which is a different node running in a different VM. It's just a storage, embedded storage again. And this one doesn't use a distributor, but a data client with Kafka again. And the merger itself will automatically merge all changes into the runnings application object graph and keep track of the changes. And a little web server again to see what's happening. So let's start it up. First the writer and then the reader. So storage is firing up. And now we say, let's take a look at the reader node first. It's empty because we haven't written anything yet. And now we can see if we add something in a server, one record is added and now it's visible on the client side in a different VM. You can use multiple nodes, of course, then the data will be distributed to different nodes. And with a intermediate layer like Kafka, the deltas which are written from the writer node are cached, and nodes which will join the cluster later will receive the changes anyway, so you don't lose any data. And so we can, of course, add more stuff, add 10 records, and they will be added to the client as well. And that's basically how the distribution works. It will merge subgraphs or lazy loaded stuff as well. So the different nodes can decide what part of the huge object graph they will keep in memory, and only the relevant data which should be merged in the graph, which is loaded by the reader node, will be merged in a live graph. The storage will be updated anyway, it has to be. And if the lazy references are requested on demand, they will have the live data from the cluster. The nodes will run completely as standalone embedded storage JVMs like the normal MicroStream storage, and the replication is a connection layer which will synchronize the data between the nodes. So for your development process, just add a client on a server side or on the writer side, and consumers on the client side, and then you develop your MicroStream application as you're used to. So no more changes are required. All right, and then last but not least, the serializer API. We have added a convenience layer on top of our serializer. There you can use a serializer for bytes and for binaries, which uses byte buffers. And these are the two methods which are used, or which are common in every serializer, I guess. You have the serialize, which converts objects to data, in our case byte arrays, and the deserialize, which converts it back to objects. So you can send the data or store your data, whatever you need to do, and the serializer will take care of it. And it has all the features MicroStream storage serializer has as well, of course, because it's based on the same library. You can use the legacy type mapping. If your classes change, the serializer will take track and care of it, and it's the safe one without any code execution at deserialization. All right, so that's the small demo from my side, and let's see what Christian got in store for us.
Okay, thank you, Florian. So that looks really great to me, especially that replication. And as I said, that brings me to the second use case. And yeah, for me, the most important use case is to create a storage cluster. I've talked about this cluster a few months ago, but in the the replication wasn't there. So yeah, this is really important for me. The idea of the cluster, I would say it's easy to explain. So we need a horizontally scaling of the storage workload. That's important. We need a high availability of the data. We want to ensure fail safety and so on. That's the reason for a storage cluster. I think that's really straightforward. So, but of course you can do it by yourself if you dare, I would say. And let's have a short look. And this is the reason also why I say the easy way. Yeah, the easy way, it looks like the easy way in the end, but when you do this by hand, or you have to take care about a lot of different things. And for example, you have to know a lot of things about Kubernetes clusters, and you have to host this on-premise, for example, or host in the cloud. You have to know exactly what to do within Kubernetes. You have to know things like Docker files. You have to know how to place them or how to place the application jars in it, how to use proxies and so on. This is on the right side. This is just a small example of some Docker files. In this case, you have to know how to handle Helm charts, for example, also with all that char stuff, messages, queue proxies, and so on. Also a small example on the right. So, and in the end, of course, you need to know a lot of application of the application itself, how to use Helidon, for example, how to use Micronaut, and a lot of different stuff. So, and that's why I've said the easy way. So let's have a short look what we planned. And if, as I said, it's still work in progress. We planned an architecture like this, and I will give you a short overview. How does this work in the end? So in the middle we have a lot of different nodes, and all of these nodes are based on one code base, and it could be, as I said, a Helidon or Micronaut project or anything else is working in this place. The important thing is we need to have a REST data provider in place, and there should be stateless, of course. And as you can see here with the colors, we have one node which is the only one which can write data. It could be also, it is also readable, but the main focus is to write the data. We have 3 read-only nodes in this case, and we have the white one. It represents the yeah, it's a new one which is created in the end if something failed in this case. On the left side, we have one load balancer, and this load balancer leads or routes the requests to the right nodes. So if there is only a read request, it will go to the read nodes, and if there is a write request, it will be routed to a proxy. This proxy takes care about the right node, so it tries to reach the right node, and if this right node is not in place, then another node keeps into the right, yeah, I would say, does the right stuff in the future. So this is managed by the proxy. And on the right side of the cluster, we have this great MicroStream graph replication feature, and this takes care about to share the data to the read nodes. And this is the reason why that graph replication is such an important feature also for the MicroStream cluster in this case. Okay, there are some more slides. I have especially some more detailed slides. As I said, we divide the read request from the writer requests, and this is based on the path of the REST API. So we have the writes here. The write will go to the orange one, and these get books, for example, can go to the reader pod, to the black one here. And this is managed by the load balancer. He does all that and well, that's a quite hard word, but he does all that things he needs to do to divide those read-write requests. And in the end, we have a proxy also in place, as I said, and he takes care about the writer pod. okay, this is the right side with the graph replication. I already explained it. That's okay. And how is the workflow, or how let's say, how will be the workflow? How does it work to create a cluster like this? And the idea is that we provide kind of like a project template, kind of like a MicroStream Cluster project template on our website. There will also be the possibility to configure this template with different stuff. So let's see what's happened then. And after that, you will be able to fill all your personal Java code, and also to create your REST interfaces and so on inside that template. In some cases, you will be able, or you can do some special configuration for the cluster. For example, the min and maximum amount of pods are running and so on. This could be configured in the project. Then you have to order a MicroStream cluster inside the cloud or wherever you want. And then you have to upload the jar. For example, it's also possible to attach, or it will be possible to attach a repository, and the cluster will be configured in the end fully automated. And this is that's the reason why I said the easy way to create a storage cluster. And that's it. Yeah, these are the three main products we are working on at the moment. Really great products, I would say. And yeah, if you have any question, feel free to ask. And that's all from my side so far. So I will hand over to Marcus.
Yeah, thank you, Christian. Yeah, really great features. And so you see, we are all very excited about these new features. So the entire team is really excited. So conclusion, we're working on distributed object graphs. So this will be the main feature, to be able to distribute any object graph of any size and complexity, run multiple MicroStream instances as a cluster. And the benefits will be, you can distribute your object graph. It will be simple to scale, and really to scale flexible in the cloud. You'll get high availability, and because of the incredible JVM performance, you will get super fast responsiveness by using streams, Java streams for searching your object graph in memory. So really gigantic workloads, and we will provide zero downtime feature and additional enterprise support features for the MicroStream cluster. It's very important to mention again, we will provide this as a service on AWS, and later on Microsoft Azure Cloud also, but we also provide this for on-premises hardware, hybrid and private cloud, so that you can decide where to run your MicroStream cluster. I mentioned it already, so we also have changed the MicroStream release cycle a little bit. So until version MicroStream 6, we provided free update support for 6 months. So this release cycle was adapted to the Java release cycle. So every 6 months, we provided a new MicroStream version, a new major release, and so we supported it for 6 months for free. Now what we have learned the last years is that it's not mandatory to go along with the Java release cycle, so that we can we believe it makes more sense to release only one major release every year, but supporting this major release for 6 more months, which means 12 months in total. So the updates will be free for 1 year from MicroStream version 7. So this is new. And then we will provide you enterprise support, which means this is long-term support for 5 years in total, but for every single MicroStream version, for every single MicroStream major release. So you don't have to think about which MicroStream major release you should choose. Just take a release, get started, and you can be sure that it will be supported for 5 years or even longer. What's in the open source version? So we didn't change too much. The data storage connectors for SQLite, PostgreSQL, MariaDB, and plain file storage are free in our open source. So we didn't change anything here. As I mentioned, we provide updates for the latest version, for the latest major release for 12 months. And this is in the open source package. Then we provide enterprise service for updates for 5 years. We provide hotfix builds for enterprise users and extended support for MicroStream releases. So if you really need update support for more than 5 years, then you can you have the chance to buy a subscription for extended update support. So this will be possible. And in addition to that, we provide you production support. So if you run your application in production, yeah, we can support this, providing 24/5 or 24/7 support. Independently from this enterprise support, we provide developer support. So when you want to get started with MicroStream coding and you need some support, developer support, yeah, you can book a developer support subscription. So this is very easy, and this is really cheap support to get started with MicroStream. That's it. Okay, that's for today. Are there any questions from the audience? Okay, no questions today. So really great new features coming up with the new version 7. And we are very excited about the new CDI extension. So this is really great for using MicroStream with MicroProfile runtimes. And of course, the new MicroStream cluster features coming up hopefully in some month. It's work in progress, but we hope we will be able to provide MicroStream cluster even in some months. Thank you very much, everybody, for joining today. Yeah, download MicroStream, play around, send us your feedback. Yeah, and yeah, hopefully you will be successful with MicroStream. Have a great day. Thank you and bye-bye.